Good morning, friends. Today, I would like to talk about mechanization and automation in welding. Uh, Even though many of the topics like mechanized system, automation, systems in welding, welding in production shops, panel line production, one-side welding, welding in building berth, robotic welding as separately mentioned in your syllabus. All these topics are interlinked. So, in the coming days, like maybe I may spend around 3 4 classes, I would be mentioning all these things together. So it is imperative that you pay attention to these slides because a wide range of topics will be covered in these classes. The basic reason is that all these things are interlinked. Without talking about welding systems, without talking about the basic production systems in basic welding systems in production shops, the basic of panel line production, one side welding, we cannot talk about mechanization and automation. And the need for mechanization and automation shall be given trust initially so as to appreciate the importance of one side welding, robotic welding, etc. So, without much introduction, let me start with the slides. A brief introduction about the automation and mechanization in welding. As we all know, the basic factors for the increase in automation and mechanization remains to be the human factors, the economic factors, and the necessity for improved quality. Apart from that, the recent thrust in the importance of safety of workmen, the importance given to the improvements in working environments also contribute to the application of automation and mechanization in all production processes, not only restricted to welding but in all production processes like painting, assembly, etc. If you say, for example, many of the industries like automobile industry have more or less fully been automated. Apart from the reasons cited above, the global competition, which necessitates cost reduction as well as improvement in quality, is one of the biggest motivator for these technological advancements. If you see joining techniques, there are a wide range of joining techniques, including adhesive manufacturing. I'm sorry, not about additive manufacturing. It's about adhesive joints, rivet joints, bolting, etc. But welding remains to be the most adaptable joining techniques, which is suitable for automation. The improvements and developments in information and communication technologies, the developments in the field of robotics, the developments in the field of big data analysis, which is a very recent trend, very recent what do you call, the one of the most sought after areas in the recent times, not only restricted to the field of industries but also restricted to the field of marketing, business administration, and most recently in the field of politics, where data are analyzed to understand the mindset of voters. Social networks are selling the data to big players to analyze the shopping habits of people, the habits of people in various countries, to influence them, so and so. So big data analysis is not only used for industries but also used in almost all imaginable walks of life. And the improvements in sensors technologies and the application of CAD CAM production line, etc., have enabled the computer integrated manufacturing in ship industries. It's in a nascent phase in Indian industries, but to be relevant in the coming years, Indian industries shall quickly adapt to computer integrated manufacturing in shipbuilding. And talking about communication technology, the advent of 5G technology will definitely improve the automation as well as industry 4.0, if you are aware about that, and also the advent of internet of things. It will enable a smooth transition from a conventional way of manufacturing to an improved or modern automated way of manufacturing. You see, automation and mechanization are more or less similar, but mechanization will be slightly affordable, and not slightly, much more affordable than fully automating the system. As we all know, the advantages of automation and mechanization would be shorter lead time, improved quality, reduced wastage, reduced labor charge, reduced reworks, and improved accuracy. Improved accuracy will definitely lead to reduced lead works, and also reduce wastage, not only with regard to base material but also with regards to power, with regards to the consumables, with regards to fuel for movement, and so forth. So all these things will lead to a sustainable development, or which can improve. No, a sustainable development means not only improving the profit, but also will be in line with the requirements of safety, the requirements of the reduced pollutions, etc. Mechanization in welding, if you talk about the Japan story, from 1975 to 2000, if you see that phase of time, the mechanization has drastically improved in the field of welding in shipyards, maybe from 0% to 40%. There are various reasons for this rapid increase in mechanization. The first and foremost is the shift from shift from shielded metal arc welding, where we use manual or labor oriented welding with stick electrodes, a transition from SMAW to FCAW or MIG welding or flux core arc welding enable this mechanization. It's because a process which is fully manual is replaced by a system where it is semi-automated, where the feed of the electrode is through a motor which is controlled with sensors, and the travel speed, if it is aided with the help of a rail guided a small wheel enabled machine, it can travel in its own capacity rather than with the aid of a welder. So these are all small mechanization which enables more productivity. Like what I meant to say was that the use of semi-automated technologies, semi-automated welding processes instead of manual welding has enabled the improved application of mechanization in welding, not only with regards to the adoption of semi-automated welding processes, but also with the developments in sister industries like electronics, like communication technology, like instrumentation where sensors are used. The rapid development in the 1980s are notoriously known as the second oil, what do you call, there was a major oil crisis in 1980s, which actually affected a lot of industry. So during that time, it's not directly related to oil crisis, but it is directly related to the fall of shipyards in the western countries. where large scale tankers were built, where large scale offshore specific ships were built. And during the early 80s, the shipyards in the European countries failed to get orders, and uh, it actually fell down from a dominant player to a less dominant player. During that time, the Korean and the Japanese industries took over the market of or took over um, the the order books of the European and the Western and other Western shipyards. So, but however, during this time, there were major developments in the field of electronics and sensors around the world, particularly in Japan, which enabled them to use these technologies in welding processes so that the intervention of manual labor can be reduced. However, the adoption of mechanization in welding in shipyards are inherited with certain difficulties. Say, for example, due to the large geometries associated with ship construction and the complex internal structures, like there will be multiple stiffeners of various shapes, dimensions, which is practically an issue for fully automation or mechanization. However, the days of shipyards with conventional welding berths and ordinary gantry cranes, which assist in material movement and assembly, and which is a highly labor oriented process, is approaching towards an end. If you analyze the man-hour spent for a particular tonnage of steel construction, continuously it is getting reduced over the century. If you analyze this particular slide, the data shown here is maybe a data collected over 100 years. Through various sources, they have collected the data and analyzed that the man hours spent for 1 ton of steel construction has reduced from around 900 to around below 550 maybe, and the time spent has been drastically reduced from years to weeks. And it happened with the aid of adoption of technologies in welding, basically. And if you see the phase from the 1970s to 1990s, or between 2000 to 1970s, we have increased the application of computer technologies, or numerically controlled machines were introduced, improved mechanization, and also adoption of various technologies enabled us to reduce the man hour per tonnage of steel to a very large extent. It is also aided with the use of heavy, what do you call, the capacity to use heavy equipments, like the development of very high capacity cranes. Then that means with improved lifting capacity, the the ability for a shipyard to compress the time period of construction per ton has also increased. Block assembly, if you talk about block assembly, the block assembly production method as is a result of development in welding technology. So as welding technology improves, the production duration for block assembly will definitely improve, and it is one of the most common method of shipbuilding today. And if you highlight the importance of welding and the importance of mechanization and automation in welding, if you analyze the expense which a shipyard spends for welding, around 10 percentage of the total cost of ship construction is taken by welding alone, which in turn is a very costly affair. And around 20 to 30 percentage of the production hours are spent only for welding. And the interesting part is that if you consider welding as a process in shipbuilding industry, actually only around 30 to 20 percentage of the time for production is spent on welding, whereas the remaining 80 to 70 percentage of the time is spent on activities which enable welding to happen. Say for example, for welding to happen, there shall be requirements of scaffolding, there shall be requirements of ventilation, lighting, there shall be requirements of material movement, etc. So there are basically a lot of activities associated with welding, which is not exactly welding but which enables us to perform the weld. So if you say around 20 to 30 percentage of production hours are spent on welding, it doesn't mean that you see 20 percentage of the time is exclusively spent for welding, whereas the 80 to 90 percentage of the time for this particular production hour is spent for activities which enables us to do weld. And coming back to block assembly, this method in this method, I think you are all aware about block assembly production. Individual blocks are constructed mostly in hull shops, which are basically covered fabrication areas, and then transported to various areas. Like there will be stages of what do you call small blocks, which will be then assembled to form a grand assembly, and then ultimately taken to the area where the ship is constructed. It can be either inside a dock or at a various building berth. Pre-erected block weight depends on the crane capacity. This is what I mentioned in the previous slide as well. The capacity of the crane to lift heavy blocks will directly influence the productivity. In principle, the following production phases are quite standard across all shipyards. Say for example, there will be flat and curved panels which are manufactured. Then pre-assembling happens with stiffness being welded. Then assembly of these pre-assembled parts to form a bigger part, then which is basically known in our yard as a grand assembly phase. And then assembling of the blocks are done, and then ultimately erection is done mainly in areas where we have heavy capacity cranes. So especially in docks where we have a 300-ton crane and also 150-ton crane. But in many yards there are crane capacities in the range of 650, etc., where they are able to accommodate a bigger size of assembled blocks. The good thing with that is that till that particular capacity, or till that particular ton of blocks, it can be assembled in the shop floor, where we have freedom of multiple equipments to be can be taken from the power sources installed in the shop floor. And then we have a better environment to work, where the accessibility to a lot of tools, a lot of equipments are easy. So the bigger the availability, or the bigger the capacity of the crane, the better the productivity improvement will be. So just to show you a very simple diagram which shows how assembly is done. Like the plates will be a nesting plan will be done, then the cutting will be done so according to the nesting plan, and then the plates are cut, and then stiffeners are also cut similarly, and then assembled over the plates to form the stiffened panels. It can be both flat as well as curved. If the plate is curved, then it is taken to a bending machine, and then and then initially a template is made with softwood or cardboards or by any means, so that the shape can be prefabricated, and then dies are used according to the required template, and then cross check with the template, and then stiffeners are placed, and then sorry, and then these are assembled to form small blocks, and then small assemblies are then assembled to form a grand assembly. And talking about various welding processes, this was what I told in the very beginning of my class. Like, if you talk about one-side welding, if you talk about various welding processes, it is not easy for us to identify the application of these things in shipyard. So if you talk about a midship section, I think you may post this slide for a couple of minutes and then understand which welding process is used in which phase. You see, yeah, this diagram is not accurate, but it will enable you to educate better about the application of various welding processes, and also in which stages of production. Say for example, there are assembly stages, there are erection stages, there are block fabrication stages. This I'm not telling that this figure is an exact replica of what we do here, but I got this figure from a particular book which talks about robotics and mechanization in welding. Here they have they have undertaken a study on Japanese shipyard called SHI Opama shipyard, and in SHI Opama shipyard they use these different processes. All these different processes are currently used in Cochin shipyard as well, like submerged duct one side, then electroslag welding, then CO2 one side welding, then CO2 semi-automated, means ordinary CO2, then SMAW, etc. So if you analyze here, almost all the vertical joints which are to be done in erection phases will be done with electroslag welding, which is actually a very high productive process of welding. And whereas most of the welding processes which are done in the shop floor, which are basically what do you call flat welding, will be done by either SAW, normal SAW, or one side submerged duct welding for thicker plates. So we will analyze what are these one side welding later, but just appreciate which welding process are used in which stages of production from this slide. There are multiple figures available in internet, but I thought being a midship section, you can see a lot of components in this, because stiffening will be much high. So what type of stiffenings will be done in what types of stiffenings, not what types of welding processes will be done for the stiffness, etc. Panel line concept. This is what I told in the beginning itself. This panel line, block assembly, etc. are all interlinked. The use of panel and block lines in the fabrication of stiffened plates is based on the principle of transporting materials through individual stations, where these individual stations will have its own specific task. Understood? So there are a lot of advantages associated with panel lines. Panel lines will increase the productivity, it will increase the quality of the well produced, because each station shall only take care of the specific task assigned to those stations, so that their jobs are well defined. The like, say for example, a particular stage will look after only welding of stiffness. So what do you call, there is a systematic streamlining of production processes, and also improved utilization of floor areas. It is not like you see, it is based on the movement, the transportation of material. So transportation of material in the sense, you see, once blasting is over, then it is immediately taken to the primer area, where in blasting process only blasting happens, in primer area or painting area only painting happens, and then it is moved to the cutting area, so on and so forth. So you see, if you design a particular welding process or production process with material transportation in mind, so that saves a lot of time, not only time with respect to material movement, but also with respect to the utilization of the floor area, so that you see there shall not be any zigzag or a random movement of material from one place to another. So in effect, a lot of space will be taken for the movement of material as well. So this panel laying concept will improve the utilization of floor area, and also it will simplify planning. This is what, if you go as per a systematic, if you know the system, and if you make a plan for the system, it will simplify it. So time for multiple planning is not needed. Just follow that simple plan, which is based on material movement or the sequence of activities. So minimum foundation work is required for installation of various equipments in the existing building, and because you see, once you establish the system, you need to identify the exact equipment which is necessary for performing that activity, and you need to install only that. Multiple equipments are not needed, like which enables multiple movements, which enable multiple production activities. So you need to focus only on the essentials, which ultimately saves in a lot of unnecessary expenses with regard to multiple purchase of multiple equipments. The opinion of shipyards are that, like 50 to 60 percentage of the steel production can pass through such a line, and this line capacity and the productivity has a major impact on the total productivity. A panel line, once used, is a well prepared way and is a key facility for a modern shipyard. This is if anyone who have visited shipyards would understand. Basically, if you visit Cochin shipyard, we follow this panel line concept, where there is a systematic movement of material with along with the sequence of, I mean, in accordance with the sequence of production process. So for today, I will wind up with this panel line concept. In the coming lectures, I will continue with further mechanisations, automations, welding systems, then one side welding. What I said is one side welding, then robotic welding, etc. So I will take maybe 2-3 classes, slides more, 2-3 presentations more, so that all these things are covered, not independently, but along with the heading of mechanization and automation. Thank you so much.